Okay, section 2.7. We're going to put together everything we learned last time. Start factoring it, see if you can find any of the answer blanks. We did one video on this already, so feel free to pause it and see how you do and fast forward it if you get it correct, right? We should be trying these on our own by now. Okay, so the first thing you should notice is that the factor on top is really, really close to matching the factor on the bottom. When that happens, and honestly, almost every time a polynomial starts with a negative, you want to take that negative out front, -1 if you want, as a GCF. So factor the top by -1 and see what happens. Remember, when we factor something out front, it gets written out front, it doesn't just disappear. So if I divide by -1, I get 2x, and if I divide by -1, I get -5, and now they do match, which from last time, hopefully you remember, that's important. That's going to help us find our holes. Let's just go ahead and do that part now. So we have 2x minus 5 over 2x minus 5, zero product property on that. If you need to, you can do it on paper off to the side. 2x minus 5 equals 0, add the 5. 2x equals 5, divide by 2, x equals 5 over 2. No calculator, so I'm going to leave it as a fraction. So I know 5 over 2, comma. Now I need to plug it in to see what y is going to equal. So now I can cross these out. I remember that they're part of my whole, and I can write what's left. So if I know x equals 5 halves, -1 divided by 5 halves plus 4. Easiest way to deal with this is to multiply everything by 2 to get rid of the 2 on the bottom. Make sure you multiply everything. -2 over these 2 cross out. 5 plus, that becomes 8. -2 over 13. So my y value is -2 over 13, and my point, my whole, is 5 halves, comma, -2/13. We still have a factor in the denominator left. That gives us a vertical asymptote. Answer that one. Zero product property gives you x equals -4. Don't forget the x equals. Horizontal asymptote, if I look at the original exponents, the degree on bottom is bigger, so the numerator is smaller than the denominator. That means I know the answer right away is y equals 0 for the horizontal asymptote. And if I have a horizontal asymptote, I know I cannot have a slant asymptote. Does not exist. X-intercepts, zeros, x-intercepts, whatever you want to call it, depending on how you answer it. X-intercepts make y equal 0, but remember, we simplified it, and then bottom doesn't affect x-intercepts, so we would get 0 equals -1, which isn't possible, so there are no x-intercepts, and that's because there's an asymptote at y equals 0, so does not exist. Y-intercept, everything that touches an x disappears, and you're left with 5 over -20, or 0, comma, -1/4. Copy down anything you need to. I'm going to erase my work in blue. Let's get a sketch. I think I can go by ones on this, so I'm not going to put any tick marks because I'm just using the graph paper that's given. So vertical asymptote at x equals -4. Dotted line straight up and down through -4. Y equals 0 for my horizontal asymptote, which is the x-axis. On your paper, make it a little bigger or make it a different color so I can see it, right? Because it's right on top of the x-axis. That leaves me 4 sections where my graph could fall, but I have a hole, so that helps me figure out where it's going to be. +5 halves, so +2.5, -2/13. So I don't know, about here is the hole. So that means it has to be down there. So it must hug the asymptote and be in the bottom right corner. That leaves two options for the other side. X-intercepts did not exist. Y-intercept, 0, negative 1/4, that's already there. So I'm going to need to plug something else in. My asymptote's at negative 4, and I want to know something on this side, right? Here or here. So let's plug in negative 5. Into our reduced equation, negative 1 over negative 5 plus 4, negative 1 over negative 1, positive 1. So it's going to be here, above the blue line, the blue asymptote, and my graph is the orange and the pink together, with the whole as a hollow dot and all my asymptotes drawn. Now let's see. Vertical asymptotes, I'm reading the directions. Vertical, horizontal, slant, holes, domain, range, increasing, decreasing. We need to do those answer blanks as well. Domain, range, increasing, decreasing. So, domain, it touches every x value except for our vertical asymptote. So all real numbers, comma, x cannot equal negative 4. That came from our green vertical asymptote, that piece, but don't forget the all real numbers. Range, it touches every y value except for, oh wait, I missed one. What else does it not touch? It also does not touch the hole. I don't know what color to make this purple. Don't forget there's a hole right here. So it doesn't touch, from my domain, it doesn't touch negative 4, and it doesn't touch 5 halves, so comma 5 halves. So for range, it touches everything except for the y value of the hole, negative 2/13, and the vertical asymptote, comma 0. You could separate them out if you wanted to also. Increasing, decreasing, remember we read from left to right, so I'm going to erase these arrows in a second. But if I read this from left to right, it's really, really slowly increasing from negative infinity until it hits... Sorry, I pressed undo too many times. So from negative infinity until it hits our asymptote at negative 4. Then if I look at the second piece, that's also increasing. But it stops increasing at the asymptote, so we had to separate them. Then it picks up again at negative 4. And it increases again until it hits the hole at 5 halves. But then it keeps increasing from 5 halves to infinity. This is never decreasing, does not exist. Okay, number 2, pause it, factor it, find all the things you can. If you're wondering how I'm factoring this in my head, I know it has to be x and x to get x squared. Now I'm thinking these two numbers have to multiply to be 6, but then negative 6. They also have to add to be negative 1. So 3 and 2. One of them has to be negative, and it has to add to be negative, so the bigger one has to be negative. X minus 3, x plus 2. We did a factoring review a long time ago. You can go back and look at that. So in my head for the next one, x multiplies to be 3, adds to be negative 4. 3 and 1 are my only options. They have to both be negative in order to work out. Pause it and see what you can do. I'm going to answer all the asymptotes. So pause your video, and the next time you press play, all the asymptote answers will be on the screen. Okay, here are all my answers with a little bit of work for each one. Check yours, pause the video, because I'm going to erase my x-intercept and y-intercept work. Remember, only the top matters for x-intercept, and all the everything touching x in the original equation goes away for y-intercept, so you're just left with the constants, and I reduced my constants. Okay, let's see. Vertical asymptote, x equals 1. Pause it and try graphing it on your own. Horizontal asymptote, y equals 1. Whole, 3 5 halves. 1, 2, 3. 5 halves is 2.5. So I know my curve is up here. It always has to be where the hole is. X-intercept, -2, 0. Y-intercept, 0, -2. Look, that time the intercepts help me. I know it also has to be in this corner. This is my graph. See if you can at least do domain and range. Let's practice that from last time because I forgot about the hole. Make sure you don't forget about the hole. Domain, all real numbers, x cannot equal 1 or the x value of the whole, 3. Range, all real numbers, y cannot equal 1 or the x value, the y value, that's what I was writing down, of the whole. Okay. Last one, get a head start, see what you can do. Okay, so for this one, if I was trying to do this, the only way to get it is 2x and x. The only factors of 11 is 1 and 11. So I could either put the 1 here and the 11 here. That's not going to make 5. Or the other way around. Or you could do an area diagram and a diamond. It's not going to work out, so this does not factor. So this is already in simplified form. Since the top doesn't factor, I don't see any matching factors on top and bottom. So there are no holes. Does not exist. Since there's only one factor in the bottom, zero product property will give me x equals -1 for the vertical asymptote. Since the exponent on top is 1 bigger than the exponent on the bottom, bigger on top means horizontal does not exist. But because it's 1 bigger, I might have a slant asymptote. So synthetic division to figure out if I have a slant asymptote. 2, 5, 11, opposite, -1 for the outside. Bring down the 2, multiply, add, multiply, add. This is the remainder and it does not equal 0, so I do have a slant asymptote, and it's y equals 2x plus 3. Y equals 2x plus 3. Copy that down because I'm going to erase my work because I need the space. X-intercepts, set the top equal to 0. If I gave you enough time to do that, you would see it doesn't work. Not only was it not factorable, but if you do quadratic formula, you're going to get an imaginary solution, which means there are no x-intercepts. Y-intercepts, everything else becomes 0, 0, 11. Let's get our sketch. I think I'm going to have to go by 2s on this because 11 is a lot. When I say go by 2s, I mean cut them in half, sorry. Okay, vertical asymptote. X equals -1. No horizontal, no hole. Slant asymptote. +3 for my y-intercept. Let's try to hit 3. And then a slope of 2. Up 2 over 1. Up 2 over 1. Try to keep that slope going. Y-intercept 0, 11. Right here tells me that my curve is inside this little piece. So that's what's happening on the right of the green line. Now I don't have any other points in my list, so I need to find out what's happening on the left of the green line. So the green line's at -1, so let's plug in -2 because I'm checking the left. That's going to be -9. So on the left of the green line, it's down at -9. Oops. I don't know, approximately here. What matters is it's definitely down below the yellow and left of the green line. This is what our sketch would look like. The answer blanks are worth the most amount of points. Hopefully you understood that and things are going better, and I hope you're doing well.